So this question is very, very similar to the one we did yesterday with the right triangle. We finished the right triangle one. It was a homework question. We're all listening to me because I have so much important information to tell you. We are closing off the first quadrant like that with a length of 20 for some reason. Do they give us a unit? 20 units. Great. Who is this? Miss Howe, how you doing?
I'm 50. You have not picked up these for your period 6 class.
Oh, well, thank you so much. So, guys, the way they define this, even though they don't give you a picture, they tell you this point up here, the top of our triangle, this is just a right triangle, is 0B. And this point down here is A0, which means this length, the vertical length is B, and the base length is A. Did you guys get this far?
Yeah.
When you read that, does that make sense?
Yeah. Well, it's kind of confusing.
So, yeah, it's a little bit weird. We haven't done one like this, but, I mean, it's basically just a right triangle, and we want to maximize the area. And everyone knows the area of a right triangle is going to be 1/2 the height, which is B, times the base, which is A. And that's going to be area. And we run into the same exact problem. We've got two independent variables, and we want to derive this thing so we can maximize it. So we got to get rid of one. And just like yesterday, A and B have to be tied together by the Pythagorean theorem. Okay? And that is our secondary equation. That must be true. And all that means is, remember we said this, you don't really get to choose A and B. Once you choose A, B is chosen for you. All right? Jihoon, good luck. Okay?
You didn't see that when I was wearing all of that.
All that means is you got to put it over your face, Danny, for that to be a good look, man. Okay. B is 400 minus A squared. Danny, I'm sorry. You're beautiful. Okay. Can we continue here? Is everyone okay with this? I'm solving for B. We're going to drop it back into my area equation. Okay? And then to optimize it, to maximize it, we're going to derive it. So we find out that A has to be 1/2 A times the square root of 400 minus A squared. We good? I just plugged it right in. And now to maximize it, we're going to derive it. So we get the derivative of area with respect to little a is equal to, by the product rule, 1/2 times that square root minus A squared plus leave the 1/2 A and derive the square root. Well, that's going to give us 1 over 2 times that same square root. Okay with that? And then by chain rule, we got to derive the inside of that, which is negative 2A. And when you multiply that, it's really just going to go up here into the numerator. So we're going to have negative 2A. Okay? And just this is the exact same thing we did yesterday, basically, except we had a 25 yesterday instead of a 400. So this is going to be rewritten so that we can solve. We got to find out where this is 0. So this is really 400 minus A squared over 2 minus A squared over 2 times the square root of 400 minus A squared. All right, any questions so far? I just simplify that right-hand side, basically. The 2's cancel out, the negative makes it a minus, and A times A makes an A squared in the numerator. Audie, what are you doing, bud? You good? You're staring pretty hard at that. Okay, just making sure. So we need a common denominator, and that's going to be the square root of 400 minus A squared times 2. So we already have that on the right-hand side here. To get it over here, we need to multiply the denominator and the numerator by the square root of 400 minus A squared. But all that's going to do, because I have a magic pen, is get rid of that square root.
I don't have a magic pen.
I'm sorry, dude. You got to rewrite it. Okay? Oh, this makes sense. Now we got a common denominator. We can put it all together. And that's going to be, in the numerator, 400 minus 2A squared over 2 times the square root of 400 minus A squared. What? So we can cancel out a 2 if we want to, right? But we just need to know, so you can do that, that's fine. We need to know where the numerator is 0, where the denominator is 0. So this is going to, whoa, my pen's acting weird. All right, this is going to equal 0 when the numerator is 0, which is going to happen when A squared is 200, which means A is the square root of 200. Okay with that? And that's the same thing as 10 root 2. And 10 root 2 is about what number? Anybody want to take a guess at that one?
16.
14. 14.
What?
Yeah, root 2 is like 1.4 or something. Okay, so 10 root 2 is about 14. And we're going to make a number line with that number. The smallest a can be from our picture, what is going on, is 0. All right? Smallest a can be with 0. Remember way up here? We have this picture. Smallest value you can let a be, the x value be 0. Okay? The largest we can make it be is what? 20. So our number line is going to go from 0 to 20. 20 is also the number that makes the denominator 0 in our derivative. Okay? So that would have gone on our number line anyway if we check that. And 10 root 2, you said somewhere around 14. And if you plug a number less than 10 root 2 in, like 1, you get 400 minus 2 in the numerator, positive. Divide it by the square root, which is positive, so you get positive. If you plug in a number bigger than 10 root 2, like 19, you get 400 minus something big, which is going to be negative. Okay? Boom. And all that shows is that 10 root 2 is the value for a, which makes the area of our triangle a maximum. All right? But they ask us specifically in the question to show that a has to equal b. All right? So if a is 10 root 2, then b, by the Pythagorean theorem, if you plug it in, remember we said that b had to be the square root of 400 minus a squared. Well, that's really the square root of 400 minus 200. Remember, a was the square root of 200. So squared would be 200. And you get the square root of 200 again. So b would also be square root of 200, which is 10 root 2. Does that make sense? And there's no units on that because they didn't give us any. All right. If you're asked to explain why we know that's a maximum, all you need to explain is that it's a max because the derivative is changing from positive to negative at 10 root 2, which creates a maximum. All good?